Good day everyone, I am Kenneth Madersi. Let's talk about the introduction to forecasting. In simple terms, forecasting means estimation or prediction of future. The prediction of outcome, trends, or expected future behavior of a business industry sector or economy throughout the use of statistics. Forecasting is an operational research technique used as a basis for management planning and decision making. Forecasting is the process of making future prediction based on past and present data. This is most commonly accomplished through trend analysis. A common example would be the estimation of some variable of interest at some future date. Prediction is similar but broader term. Next is the features of forecasting. So first feature is it is concerned with future events. Second, it is necessary for planning process. Third, the impact of future event has to be considered in the planning process. Fourth, it is a guessing of future event. Fifth, it considered all the factors which affect organizational functions. Last is personal observation also help forecasting. The next is forecasting horizon. So, the first forecasting horizons is long-term forecasting. The time frame is generally considered longer than 2 years into the future. It tends to be completed at a high level in organization due to a high degree of uncertainty. Detailed knowledge of the product and market is required. This is frequently the case when new products enter the market, new technologies emerge, and new facilities open. There is frequently no historical data available. Second is medium-term forecasting. It is tend to be several months up to 2 years into the future. Both quantitative and qualitative forecasting may be used in this time frame, and it is known as a intermediate term in this time frame. Both quantitative and qualitative forecasting may be used. So next is the short-term forecasting, predicting only few periods ahead, hours, days, or weeks. Usually quantitative methods such as time series analysis are used in this time frame. Is from today to month. In the future, these forecasts are used to make operational decisions such as inventory planning, ordering, and workforce scheduling. In this time frame, quantitative methods such as time series analysis are commonly used. The three principles of forecasting. So, number one is forecasts are rarely perfect. So, there are too many factors in the business environment that cannot be predicted with certainty. Now, number two is forecasts are more accurate for groups than for individual items. So, a higher degree of accuracy can be obtained when forecasting for a group than for individual items. Their individual high and low items cancel each other out. Number three is forecasting are more accurate for shorter than longer time horizon. So, it means data does not change much in the short-term run. The next is steps in the forecasting process. So the first step is decide what to forecast. Remember, forecasts are made in order to help plan for the future. We have to decide what forecasts are actually needed to guide the plan. Number two is analyze appropriate data. It is important to identify which pattern are present. The most common data are number one, level or horizontal. It is common for commodity product in the mature stage of life cycle such as table salt or toothpaste. B is trend. So trend refers to the increasing or decreasing pattern over time. C is seasonally. Any pattern that regularly repeats itself, like ice cream sale in summer or snow shovel in winter. Letter D is cycle. Do not have a predictable or repeating length or magnitude. They are the most difficult to predict. So the next step in forecasting process is select the forecasting model. Once data pattern have been identified, the next step is to select the appropriate forecasting model. So the fourth step is generate the forecast. It is by using the data. Number 5 is monitor forecast accuracy. So this information should be used to improve the forecasting process. Remember, forecasting is an ongoing process. Let us proceed to factors in method selection. So the first factor is the amount and type of available data. It means a different forecasting method require different types and quantities of data. Number 2 is degree of accuracy. Um, the cost of the forecasting method needs to justify the importance of the forecast. So the third is length of the forecast horizon. Some forecasting methods are better suited for long terms. Number 4 is pattern in the data. It is critical to select a forecasting model that appropriate for the identified pattern in the data. Next is the type of forecasting method. So the quantitative forecasting method, it is the method based on a subjective opinion and judgment of individuals such as managers, sales staff, or customer. Number 2 is quantitative forecasting method are generally more accurate than qualitative method. They are required data in qualifiable form. The next is the qualitative forecasting method. There are 4 qualitative forecasting method. The first is executive judgment. Second is sales force opinion. Third, development method. Fourth is market survey. So executive judgment, which is typically when we're looking at a group of executive, then they're going to make decision or an opinion about what's going to happen in the next period. Next is sales force opinion. Typically see quite a bit where you've got individual sale people, then they make their own sale forecasting estimate. The third is Delphi method, consumer or just trusted advisor that they give their own opinion about what they think is going to happen on how many widget they buy or how many widget they think would be sold in different market, and then they group that they group and compile all information and give them to the decision makers. Last is market survey. So market survey is, would you purchase this or how would you purchase this?
The qualitative forecasting methods. We have the executive judgment, top down. A group of managers, executives, or sales staff meet and collectively develop a forecast. It is often used to forecast sales, market trends, make strategic forecast, or forecast new product. Forecasts are frequently assigned to groups of high-level executives. They will work together to analyze market data and forecast the future business trends. To make a forecast, they frequently employ statistical models as well as market experts. Second is the sales force opinions, bottom up. It is the bottom-up approach where the sales force gives their opinion on sales trend to the top management. A company's sales force is the people who are closest to the customers. Their perspective are highly valued. Salesforce personnel are frequently asked to provide future projections for their area or territory. After reviewing all of them, they can be combined to form an overall forecast for district or region.
The next forecasting method is Delphi method. Questionnaire are sent to expert, the findings summarized, and then process repeated until consensus is reached. It is excellent to forecast their long-range demand, technological change, and scientific advances. So Delphi method, consumer or just trusted advisor that they give their opinion about what they think is going to happen on how many widget did buy or how many widget they think would be sold in different market, and they got group that compile all information and give them to the decision makers. The next method is market survey. Use survey and interview to determine customer like, dislike, and preference, and to identify new product idea. So market survey is, would you purchase this or how would you purchase this?
Quantitative forecasting methods. First, we have the causal models. variables being forecast is related to the variables in the environment. For example, including information about the climate patterns might improve the ability of the model to predict umbrella sales. Forecasting models frequently take into account regular seasonal variation. Aside from climate, such as variation can be caused by holidays and costumes. For example, one could predict the sales of college football apparel will be higher during the football season than during the off-season. Next is the time series model. Generate forecasts from an analysis to time series of data. Data over time taken at regular intervals. For example, students' enrollment per semester over the past 5 years. Time series methods estimate future outcomes using historical data. A time series is a collection of data points that has been indexed or listed or graphed in time order. A time series is most commonly defined as a sequence of photos taken at evenly spaced point in time. As a result, it is a series of discrete time data. Time series examples include ocean tide heights, sunspots counts, and Dow Jones Industrial Average Daily Closing Value. The causal models. One of the most famous causal models is regression analysis. So regression analysis, it is a set of statistical methods used for estimate of relationships between a dependent variable and one or more independent variable. In statistical modeling, regression analysis is a set of statistical processes for estimating the relationship between variables. It encompasses a wide range of techniques for modeling and analyzing multiple variables when the focus is on the relationship between a dependent variable and one or more independent variable or predictors. More specially, regression analysis explains how the typical value of the dependent variable changes when one of the independent variable is changed while the other independent variables remains constant. Linear regression. It is used to predict the value of variable based on the value of another variable. The variable you want to predict is called the dependent variable. The variable that you are using to predict the other variable's value is called the independent variable. Linear regression is a supervised machine learning method used by the train using AutoML tool to identify a linear equation that best describes the relationship between the explanatory variable and the dependent variable. This is accomplished by using least squares to fit a line to the data. Multiple regression. It is a statistical technique that can be used to analyze the relationship between a single dependent variable and several independent variables. Multiple regression analysis enables researchers to assess the strength of the relationship between an outcome, the dependent variable, and the several predictor variable, as well as the importance of each predictor, the relationship, frequently when the effect of other predictors statistically eliminated. Demand patterns. When we plot our historical product demand, the following pattern can oftenly be found. First, we have the trend. A trend is a consistent upward or downward movement of the demand. This may be related to the product's life cycle. A cycle is a pattern in the data that tends to last more than 1 year in duration. Often, they are related to events such as interest rates, the political climate, consumers' confidence, or other market factor. Third is the seasonal. Many products have a seasonal pattern, generally predictable changes in demand that are recruiting every year. Fashion products and sporting goods are heavily influenced by seasonality. Fourth is the irregular variation. Often demand can be influenced by an event or series of events that are not expected to repeat in the future. Examples might include the extreme weather event, a strike at a college campus, or a power range. Fifth is the random variation. Random variation are the unexplained variation in demand that remains all other factors are considered. Often this is referred to as noise. So we have here the horizontal, trend, seasonal, and cyclical. It shows here the illustration for the demand patterns. Quantitative forecasting methods. First, we have the naive approach, looking at what happened in the previous period that's going to happen again. Moving average might say, okay, the last period if we take what happened to the last 3 periods. Exponential smoothing. It is a matter of taking a weighted average approach. So we are going to weight a different period differently because they are more relevant to the forecast. Trend projection, where we look at the trajectory of what's happening. Maybe we're increasing every single period or had to increase a small decrease and then another increase. Time series forecasting model. First is the naive method, the simplest forecasting method. In this case, the forecast for the next period is set at the actual demand for the previous period. A naive approach consists of calculating a histogram of angles, assuming the accumulation of points corresponding to the direction of interest will result in visible peaks. Next is the simple moving average. It is simply the average price over the specified period. The average is called moving because it is plotted on the chart by bar, forming a line that moves along the chart as the average value changes. Simple moving average calculates the average of range of price by the number of period within that range. A simple moving average is technical indicator that can aid a determining if an asset price will continue or if it will reverse a bull or bear trend. Some relevant notation is the DT, or the actual demand observed in a period T. FT is a forecast for period T.
Here is an example of simple moving average. In this method, we take the average of the last n periods and use that as the forecast for the next period. The value of n can be defined by the management in order to achieve a more accurate forecast. For example, a manager may decide to use the demand values from the last 4 periods, n equals 4, to calculate the 4-period moving average forecast for the next period. Again, some relevant notation are D sub T equals actual demand observed in period T. F sub T equals forecast for period T. Using the following table, calculate the forecast for period 5 based on a 3-period moving average. Period 1, 2, 3, and 4, and for the actual demand for the period 1 is 42, for the period 2 is 37, period 3 is 34, and for the period 4's actual demand is 40. Solution. In calculating the forecast for period 5 is F5 equals D4 plus D3 plus D2 divided by 3. D4 is 40, while D3 is 34, D2 is 37. 40 plus 34 plus 37 is 111, and 111 divided by 3 is 37. Weighted moving average puts more weight on recent data and less on past data. This is done by multiplying each bar's price by a weighting factor. This method is the same as the simple moving average with the addition of a weight for each one of the last n periods. In practice, these weights need to be determined in a way to produce the most accurate forecast. Let's have a look at the same example, but this time with weights. The weight for the period 2 is 0.2, for the period 3 is 0.3, and for the period 4 is 0.5. And for the solution is Forecast for period 5 equals F5 equals 0.5 times D4 plus 0.3 times D3 plus 0.2 times D2 equals 0.5 times 40 plus 0.3 times 34 plus 0.2 times 37 equals 37.6. Note that if the sum of all the weights were not equal to 1, this number above had to be divided by the sum of all the weights to get the correct weighted moving average. Exponential smoothing is a time series forecasting method for univariate data that can be extended to support data with a systematic trend or seasonal component. This method uses a combination of the last actual demand and the last forecast to produce the forecast for the next period. There are a number of advantages to using this method. It can often result in a more accurate forecast. It is an easy method that enables forecasts to quickly react to new trends or changes. A benefit to exponential smoothing is that it does not require a large amount of historical data. Exponential smoothing requires the use of a smoothing coefficient called alpha. And for the formula is f sub t equals f sub t minus 1 plus alpha and the difference of d sub t minus 1 and f sub t minus 1. Example, assume you are given an alpha of 0.3 and the f sub t minus 1 equals 55. Period 1, 2, 3, 4, 5 and the actual demand are 60, 55, 51, 58 respectively. Assume that the f sub t minus 1 is 55. For the period 2, 55 plus 0.3 which is the alpha times 60 which is the actual demand for the period 1 minus 55 which is assumed to be the f sub t minus 1 is equal to 56.5. And the total forecast for the period 2 is the f sub t minus 1 of the period 3 which is 56.5. And for the period 3 is 56.5 plus 0.3 times 55 which is the actual demand of period 2 minus the f sub t which is 56.5 and is equal to 56.05. The following periods are the same computed as follows. Seasonal index is a measure of how a particular season through some cycle compares with the average season of that cycle. Many organizations produce goods whose demand is related to the seasons or changes in weather throughout the year. In these cases, a seasonal index may be used to assist in the calculation of a forecast. For example, season, previous sales, average sales, and seasonal index. For the season are winter, spring, summer, and fall. The previous sales of winter is 390, and for the spring is 460, for the summer is 600, and for the fall is 550, which has a total of 2,000 for the previous sales. And for the average sales are all 500 for all the seasons. The seasonal index for the winter is 390 divided by 500 is 0.78. For the spring is 460 divided by 500 is 0.92. And for the summer is 600 divided by 500 is 1.2. And for the fall is 550 divided by 500 is 1.1. Using these calculated indices, we can forecast the demand for the next year based on the expected annual demand for the next year. Measuring forecast accuracy. In this section, we will calculate forecast accuracy measures such as mean absolute deviation or MAD, mean squared error or MSE, and mean absolute percentage error or MAPE. Two of the most commonly used error measures are the mean absolute deviation and the mean squared error. Measuring forecast accuracy tells us how our forecasting methods are performing and enables us to improve performance over time. The first step in measuring forecast accuracy is to measure the forecast error. Forecast error is the difference between actual demand and the forecast for a given period. Both error measures provide different information, and a good forecaster learns to rely on multiple measures. Example of measuring forecast accuracy. The following actual demand and forecast values are given for the past 4 periods. We want to calculate mean absolute deviation, mean squared error, and mean absolute percentage error for this forecast to see how well it is doing. Note that absolute value refers to the absolute value of the error in period T. For the solution, here are what we need to do. Step 1. Calculate the error as A sub T equals D sub T minus F sub T, the difference between the actual demand and the forecast, for any period T, and enter the values in the table above. For example, in period 1, the actual demand is 63 and the forecast is 68. We will get the difference of the actual demand, or the D sub T, and the forecast, or the F sub T. So 63 minus 68 is negative 5. Step 2. Calculate the absolute value of the errors calculated in step 1 and enter the values in the table above. So in period 1, the absolute value of the error, which is negative 5, will be positive 5. Step 3. Calculate the squared error for each period and enter the values in the table above. In period 1, the absolute value, which is positive 5, will be squared. So 5 squared is 25. Step 4. Calculate absolute value divided by the actual demand times 100% for each period and enter the value under its column in the table above. In period 1, we will divide the absolute value, which is 5, and the actual demand, which is 63. So 5 divided by 63 is 0.079, and we will multiply it to 100% and we will get 7.936 or 7.94%. And for the rest period are calculated the same. And for the equations and computations for forecasting for the naive approach, moving average, and exponential smoothing are to be further discussed by the next group reporters. And for the summary are, forecasting is the process of predicting future events, planning is the process of selecting actions in response to the forecast, marketing forecast size of markets, new competition, future trends, emerging markets, and changes in consumer preference. Financing in turn uses forecasting to assess financial performance, capital investment needs, and set budgets. Operations makes decisions regarding production and inventory levels, conducts capacity planning and scheduling. Sourcing uses forecasts to make purchasing decisions and select suppliers. Qualitative forecasting methods are methods based on subjective opinions and judgment of individuals such as managers, sales staff, or customers. Quantitative forecasting methods are generally more accurate than qualitative methods. They require data in quantifiable form. Linear regression. It is a forecasting model that assumes a linear or straight line relationship between two variables. Multiple regression. It extends linear regression by looking at a relationship between the independent variable and multiple dependent variables. Measuring forecast accuracy tells us how our forecasting methods are performing and enables us to improve performance over time.